Okay, so hopefully the final video. This one's going to be on fractions and a little bit on percentages too. So let's find the right page. That one. Lovely. Right. Adding fractions. Adding and subtracting fractions is actually the harder part of fractions. Multiplying and dividing are a little bit more straightforward. So, adding fractions. Basically, we've got our fraction is made up of two parts. We've got a numerator at the top and we've got a denominator at the bottom. The denominator tells us how many parts we have for a whole one, and the numerator on the top tells us how many of those parts we have at the minute. Okay, so it's a number that's less than 1, effectively. And this one says we've got 2/5. So if I've got one whole there, okay. If I've split it into fifths, it will be split into 5 equal sections. Okay, and I've currently got 2 of them, so I've got those 2 there. Okay, that's my representation. If that whole bar was 1, I've got less than 1 because I've only got 2/5 of it. Same thing for the next number. I've got 3/4, so I've got 3 out of 4, or if we talk about pizzas, I've got 3/4 of a pizza, so there's a quarter somewhere else, hopefully. Alright, now if I'm going to add them, I can't add fifths and quarters together because they're not the same, they're not compatible. So I must make sure that I convert my fractions to equivalent fractions of themselves, but they then both have the same denominator, so I've got this out of the same number of parts, so then I can add the 2 together and then hopefully get the right answer. So if I look at those 2 numbers, I'm basically looking for common multiples. So a number that is in both the 5 and the 4 times table. And the obvious one is 20 if I times the 2 together. There isn't one that is smaller than that, so that's the one I'll start with. So to convert both of my fractions into equivalent fractions that are out of 20 parts, I need to do a bit of multiplication. So 2/5, if I multiply fifths by 4, I end up with 20. So if I times that by 4, I get 20, so I have to do exactly the same thing to the numerator at the top. So 2 times by 4 is 8 over there. Then the other fraction, if I'm looking for a number that multiplies by 4 to get 20, it's obviously 5. So 4 times by 5 equals 20, so I have to do exactly the same thing up there. 3 times by 5 is 15. So now I've got my 2 fractions, I've got the same denominator, and I can simply add them together. Now what I don't do is I don't add my denominators together because that's how many parts I've got it out of, so that is how many examples. So my answer is going to be out of 20, okay, a denominator of 20, and I simply add the 2 numerators together. So 8 plus 15 gives me 23. Now, that, in theory, is the right answer because I've added the 2 fractions together, I've got 23/20. Often the children are asked, can they simplify it down to a more simpler fraction? These original fractions were simpler than these. Okay, so I need to sort of see if I can simplify it down. Actually, I can't find an equivalent fraction that will simplify that down because 23 being a prime number I'm not going to be able to do it. But what I can do is I've got 23, so I've got more than a whole one because I've got 23 parts. So if I take 20 away, I've got a whole one and I've got 3 left. So what I can do is I can simplify it slightly and put 1 and then 3/20, okay, because that's exactly the same thing. I've got 1 whole one and I've got 3/20 left. Again, I can't simplify that down because I don't have a common factor between 3 and 20, so I can't make it any simpler. That's adding fractions. Subtracting fractions, exactly the same process. I have to make sure I've got common denominators, and then I'll just subtract the numerators instead of add them. So, look at my 2 denominators. The number that springs to mind is 15, because 15 is in both those times tables. So I'm going to convert them both to denominators of 15. Now, this one, to get to 15, I obviously times it by 5, so I'm going to times that one by 5 too. 2 times by 5 is 10. And this one has to times by 3 to get to 15. So 5 times by 3 is 15. 4 up here times by 3 would be 12. So now I have got a you can probably see that it wasn't supposed to be that way around. Doesn't matter. All I've got is I've got the same denominator, so very simply I can do 10 take away 12, which is minus 2, and then I've got a 15 on the bottom. Just because it's a minus fraction doesn't really matter. We had negative numbers in one of the previous videos. It can be a negative number. To be honest, the children probably won't get asked to give negative fractions, but we're just trying to show you the process. So it's just a case of taking that numerator away from that numerator, and it gives you the answer. Okay. Again, I can't simplify that because these two numbers don't have a common factor, and so therefore that would be my answer there. I could, had these fractions been the other way around, and actually I probably should have put them the other way around before I did this, my answer of course would have been 2/15, not negative 2/15. I hope that's clear. Alright, multiplying fractions. This is much easier than subtraction or addition, because we just multiply straight across. So all I have to do is I multiply my numerators together, so 1 times 4, and I multiply my denominators together, so 12 times by 5, 1 times by 4 is 4, and 12 times by 5 is 60. Now I look at those two numbers and I can start to see some common factors, so I need to simplify that down a little bit. 60 doesn't divide by 4, so I can't do that, but I know that I can divide both of them by 2. So if I divide both of them by 2, I end up with a 2 on the top. Okay, 4 divided by 2 is 2, and if I divide that one by 2, I end up with 30. Okay. Now, I'm now looking at this and thinking, actually, 60 does divide by 4. So if I again divide that one by 2, I get 1, and I can divide 30 by 2 to get 15. Okay, so my answer in its simplest form is 1/15 here. But all I've done is multiplied the numerators together and multiplied the denominators together. If excuse me, if my question was 1/12, and I was multiplying it by a whole number, 4, okay, 4 as a fraction is exactly the same as 4 out of 1, because I've got, if 1 is a whole one, then if I've got 4 parts, I've got 4 whole ones. So you can see here that I end up doing 1 times 4 and 12 times by 1 to work out what my fraction would be. Okay, so I end up with 4/12. The denominator is never going to change if I'm multiplying by a whole number, because the denominator in the second fraction is always going to be 1. So we teach the children to just multiply the whole number by the numerator, and that will give us the fraction. If I simplify that down, I can simplify that down to 1/3. Okay, because 4 divided by 4 is 1, 12 divided by 4 is 3. Right. Dividing fractions, same process, almost. When we're dividing by a whole number, okay, again, that fraction really is 5/1. Okay, that fraction is 5/1. So what I do is I have to flip my fraction upside down, and then I multiply. So I've got 7 over 8 multiplied, if I flip my fraction over, multiplied by 1 over 5. Okay, then we go back to exactly the same method that we did here, where we multiply the two together. So 7 times by 1 over 8 times by 5. Again, I work it out. So 7 times by 1 is 7, and on the bottom, my denominator, 8 times by 5 is 40. So I've worked out my answer. Does 7 go into 40? No, it doesn't, because 6 times 7 is 42. So they're not compatible. 7 is a prime number, so I'm going to struggle to make that any simpler than it is. So I'm going to leave it as it is. Now, if you've noticed that I have taken my fraction of 5/1, flipped it, and multiplied. If I'm dividing by a fraction, then obviously I still flip it and multiply. The children don't very often get asked to divide fractions, by a fraction. Normally it's by a whole number. So actually what we taught the children is they don't really need to worry about that over 1 to overcomplicate it. They can simply, when they're dividing by a whole number, just times that number by the denominator, and it gets them the same answer, because I'm always going to be multiplying by 1 at that stage if it's a whole number. Okay? Percentages. Can be a little bit tricky, but really fairly straightforward. So 20% of 2,100. First, what we've done is we've taught the children to find 10%. If they can find 10%, that really helps them, because it's really simple to find 10%. All they need to do is divide the number by 10. So they're doing 2,100 divided by 10 to find out what 10% is. The children should know that dividing by 10, they move all of their digits one place to the left. There's 1, 0 and 10, so they move all of their digits one place to the right, sorry, not the left, to the right. Okay. So 2,100, if I move all of my digits over, okay, if I keep my decimal point there, the 0 ends up in there, that 0 ends up in there, that 1 ends up in there, and then the 2 ends up over there. That doesn't quite work, it sort of does. Okay, so I end up with 210. So that is my answer, 210. That gives me 10%. In this case, I need to find 20%. So all I do is I take my 10%, which is 210, whoops, and I multiply it by 2. And that gives me 420, and that would therefore be the answer to my question up here. Now, if they needed to find 1%, perhaps they could divide 10% by 10 again, or they could take the original number and divide it by 100. That would give them 1%, so if this said, what was 22%? I've got 20%, I'd need to work out 1% to then add on double that. Or I could half 10%, okay, and that would give me 5%. So 5% would equal 105, because I've halved what 10% is. Half 10% is 5%, so I've halved it down, and then if I had to work out what 25% was, I could do it like that. Okay, of course, 25%, I could find a quarter of the original number and just divide it by 4. There are lots and lots of different ways you could do it, but that's the way we've told them that will hopefully be bomb-proof.